Hey everybody, this is Pete, and in this video I want to demonstrate a kind of a workflow I've been developing and contemplating based on some feedback that I have from a customer who, well, the scenario is they've got an older, wise, great designer who lays out all the electrical components, but the newer designers, of course, don't have all that experience, so they sometimes put components too close together, or they have a situation where maybe they didn't leave enough room for the wiring to get connected properly. So what I wanted to take a peek at is trying to find a way where we could capture some of this assembly information. So it's not really like a tolerance issue per se, like will these two pieces fit together? I mean, tolerance analysis is great for that. This is more along the lines of, do I have enough space for this thing? Do I have enough clearances around it for various ideas? So what I've got is I've got this shape. So it's just a little electrical component, just a pretend little guy here, that's going to be bolted in at the top. It's got a little little pivot thing here so you can kind of slide it and rotate it into place. And of course, it's got a little tab that would be the connection for the electrical component. And what I've done is I've generated a number of solids. There's the yellow one, which is going to represent like how much thermal clearance you need, like this component gets hot. The blue is tool clearance to make sure that we have enough room to get the socket or whatever and to bolt the part in place. The green is going to serve as the space to make sure we've got enough room to make the wire connection. And then this white one is basically just, can we have enough room to install it? So we pivot that shape into place, and then we rock and roll from there. So that's the idea with the components. So we're capturing not so much tolerance information, but more like assembly information. And then because these are solids, we want to be able to use the analysis tool for analyzing interferences to make sure these things aren't overlapping, causing a problem. So what we need to do is also control these solids. So they have to be solid shapes, which you can see here, but I don't want them on all the time because, of course, they impact the mass. So what I've decided to do is I'm going to give you 3 different ways to control this, depending on which version of Inventor you have and if you think this technique could be beneficial. So the first method is what I call conditional suppression. So conditional suppression is up here where you create a parameter, you set it to be a value. Now I like to use 1 and 0, 1 for true, 0 for false, or however you want to do that, 1 for on, 0 for off. And what happens is I can then use that to control a value. So you go to one of your solids, your features like this extrude, look at the properties, and I can do what's called conditional suppression. If clearance bodies equals 0, then turn it off. So the blue represents the tooling, making sure that I have not enough room for like a socket. So that would be controlled, that would be turned off if I toggle the value. So to do that, I haven't added this one yet. We would right click on it, go to the eye properties, just say if the parameter, I made it easy, there's only the one, equals 0. Now whenever we toggle this to 0, now you're back to just the base component. So that's one way to control this, all right, using conditional suppression. Now another way we could control whether or not these bodies show up is good old-fashioned iLogic. So again, we've got the value. I was waiting for it to show up. Oh, hold on. There we go. So again, same idea. We've got a parameter, and we can say show the clearance bodies true or false. And then what happens is it will cycle through all of the features. And if it starts off with clear, right, so we're going to consistently name these things, then it'll turn it off if it's not true. And then if it is, then yeah, let's make sure we make them happen. So again, just an iLogic method. It's the same idea as conditional suppression. So maybe a little bit cleaner, a little bit less work, but if you're not familiar with iLogic, you could of course use the conditional suppression. So this will work in almost any version of Inventor, but then again, starting in 2022, they had model states. So if we look at the model states, this is where I've created a model state that suppresses these, or I've got a model state that shows them. So it's just about activating the finished part, right-clicking, and we suppress the features that we want, and then we make sure they're unsuppressed in the model state that shows it. So that's the idea. So we've got a couple different ways that this could work. I'm going to go backwards now. So if we go to the Inventor 2022, you can see I've placed the components, and then the components are in their final finished part state, right? I've got a small pattern of them, and I want to see if they overlap. So what we could do is we could create a model state here at this assembly. This is just our test assembly. Right-click, New. And if you name your model state exactly the same way, so a lot of copying and pasting is useful here, we can link the two model states together. And that's in your productivity drop-down. Find the link model states, link it to clearance bodies, hit OK. It says, are you sure? I'm always sure. So now they're linked. So whenever at the assembly level I would want to see the clearance bodies, I can turn that on, toggle back, turn them on. Okay. Now one last thing, if I hit open here, this is where we have the design test. Well, we can utilize iLogic for this as well. So I like to have an external rule that does this also. So if you didn't have 2022, you could have an iLogic rule. It's a pretty simple rule. I'm using an external rule. You don't have to. Could live in the assembly. But it's basically checking every single component occurrence, and if it has the show clearance bodies parameter name in it, so again, we want to have a consistent parameter, then I'm going to set the value of that component's parameter value equal to the assembly level parameter. Okay, so in this case, in the assembly itself, it also has the show clearance bodies. I can say false. I don't have it linked up just so you can see. You just run the rule and it grabs the value and turns them on or off. Okay, so again, you could do that via iLogic, or if you have 2022, you could use the model states, either way. But the whole point of this is if we go to the Inspect tab, we can take a look at the Analyze Interference tool. I can pick all of the solids, hit OK, and what happens is it shows me the various interferences. And we can take a look at the specific ones if we want. But what I have going on here is it's looking at the thermal interferences, the tooling interferences, and in this case, a little bit of a wedge of the install, meaning there might not be enough room to get this in place. So that's the whole point, is I wanted some sort of tool that allows people to take a look and say, is this going to fit? So to fix it, of course, we can make a change here. So I have this just as a multi-body, and I'll just change this really quickly. So I'll make this a bit taller. See, that's going to raise that flange up just a little bit. And then if I go back to the one I was working on, of course, we'll update that design. And now when we run the Analyze Interference again, now it has eliminated some of them, right? So we can see that we can now install the shape. There's plenty of room for this to fit in here. There's no thermal interferences on the top part, but these components are still close together. So we would have to space them out a bit. That's the whole point of trying to do this, is I wanted to give the newer engineers a way to be able to quickly tell, am I putting these electrical components together properly? So I wouldn't do this for every design, but I think in certain situations where we have a lot of repeatability and we can have critical issues, like we don't want something to overheat or even worse, potentially start on fire, I thought this could be an interesting workflow to try and accomplish that. So I'm curious if you have any thoughts about it. Just go ahead and share those in the comments below. Hope you found it interesting. This is the kind of stuff I really enjoy doing, is trying to solve these types of problems. And yeah, just hope you find it beneficial. Have an awesome and blessed day.